Alright, so this is part 2 of graphing polynomial functions. In this video we are going to talk about turning points and how to find them. You will need a calculator of some sort. I recommend desmos.com and the link is on Google Classroom. So what the heck is a turning point? It's the point or points where a polynomial switches direction. The higher points are called relative maximums and the lower points are called relative minimums. So in my graph down here, this higher point here would be a relative max. This lower point down here would be a relative minimum. Okay, now in between we have increasing and decreasing intervals. Okay, so think of increasing. We read a book left to right, so we read a graph left to right. So as you go left to right, if an ant were crawling along this line, the graph is increasing when the ant is crawling uphill. So for example, if you look at this section of graph here, that would be a portion where the ant is crawling uphill. So this is increasing. Okay, we have another section over here on the right hand side. That is also a point where the ant is crawling uphill, so that means it is increasing. Now if you look in between, decreasing is whenever the ant is sliding downhill. Okay, so right in between there, that would be a decreasing interval. And whenever we write these intervals, we're always looking at the x values, okay? And we'll get more into that here in just a second. Okay, so let's look at a function. We have f of x is equal to x cubed minus 6x squared plus 7x plus 2. I would recommend graphing this on Desmos. I have attached a picture of what you would get on Desmos. And so I want to find the relative maximum, the relative minimum, increasing intervals, and decreasing intervals. So if I look on my graph here, let's find the relative max. That's the highest turning point. It's going to be this guy right here. And so you write that coordinate point. So 0.709 and 4.303. That's your relative max. Your minimum is going to be down here, so write that coordinate point, 3.291 and negative 4.303. So those are your maxes and mins. We can also call these extrema. Okay, it's just another name for relative maxes and mins. So now let's look at the increasing intervals and decreasing intervals. So if I were to read left to right, where would the ant be crawling uphill? It would be this section here and this section here. So how do we write that as an interval? So it's always going to depend on the x values. So you're going to look at your x values of your maxes and mins. And those are going to be the boundaries, okay? But if in this case, this graph is going downwards forever. And if you remember, whenever we talked about domain and range, if it keeps going, it goes both in the vertical direction and horizontal direction. So this function is actually increasing. Over here is negative infinity, and over here is positive infinity. So it's increasing from negative infinity all the way to this x coordinate, so 0.709, okay? But there's a second interval where it's increasing. So we combine the two with a union symbol. It just looks like a U. And this interval, it starts at 3.291, and this function increases to infinity. Okay, so that's how you would write your increasing interval. Now the decreasing is just a little bit different. Okay, let's get a different color here. All right, so decreasing is going to be in between those maxes and mins. So the x value where it starts to decrease is 0.709, and where it stops decreasing is at 3.291. Okay, and so if you notice, between your increasing and decreasing intervals, you should have the entire x axis covered. So we start from negative infinity, we go to 0.709, then we pick it up back down here at the decreasing interval and go to 3.291. We pick that up back on increasing, and then we go all the way to infinity. Okay, we'll do some more examples. All right, so let's look at f of x is equal to negative x cubed plus 3x squared. Again, I recommend graphing this on Desmos. So you want to find all of these different features. So domain, range, relative max and min, end behavior, increasing and decreasing intervals. For a polynomial function, more than likely, I'm not going to say always, but more than likely, your domain is going to be all real numbers. So there's two ways that you can write it. X is an element of the reals, or you can go from negative infinity to positive infinity in interval notation. Okay. Now the range can change with a polynomial function. In this case, since my graph is going down at the very bottom and then up at the very top, my range is also all y values. So y is an element of the reals, or you can say from negative infinity to positive infinity. Okay, now let's look at the relative max. So that's the turning point that's the highest, which is going to be this point here. So 2, 4 is your relative max. Your relative minimum is this lower point down here, 0, 0. And so your increasing and decreasing intervals should be between those x values, 0 and 2. Okay, and we'll get to that in just a second. Let's talk about end behavior. So as x goes to infinity, where is the function going? So as you're going to the right, is the function going down or up? So it's heading down towards negative infinity. As you look to the left, towards negative infinity in the x direction, where is the graph going? In this case, it's going up towards positive infinity. Now comes increasing and decreasing intervals. So I'm just going to go from left to right. So in this section here, the ant would be sliding down the hill, so it is decreasing. We also have a second decreasing interval right there. And so let's name that interval. Well, starting on the left-hand side, it starts at negative infinity, and then it stops decreasing at this minimum value, so at 0, when x is 0. Remember, if you have two intervals, you connect them with a union symbol. And then my second interval starts right here when x is 2, and it goes until positive infinity. My increasing interval is in between those values. Okay, so it's this section right here. The ant is crawling uphill. So between those maxes and mins, you look at your x values, so you're increasing from 0 to 2. Okay, and that's how you name increasing and decreasing intervals. Okay, let's do one more. We have f of x is equal to negative x to the 4th plus 4x squared minus 3x minus 2. I have graphed that function down below here. You can do that on Desmos. So let's look at the domain. Again, If it's a polynomial function, your domain is more than likely going to be all real numbers. So x is an element of the reals. That's one way you could write it. Or from negative infinity to positive infinity. The range can change. Okay, remember we do range from bottom to top. So if you look at this graph here, my graph is mainly like on the bottom half of the graph. It does not exist any higher than this point here. Okay, so my range is from negative infinity all the way to that y value, which is 6.494. Okay, so that's my range. Now let's look at relative maximums. Okay, I have two. I have one here, and I have one there. Okay, so I have two relative maximums, so negative 1.574 and 6.494. And the second one is 1.164 and negative 1.908. Okay, so those are my two relative maximums. I have one relative minimum down here at 0.409 and negative 2.586. Okay, so our increasing and decreasing intervals are going to be between those values only, those x values. Okay, but first let's look at end behavior. So as x goes to positive infinity, so looking at the right hand side, where is the graph going? It's definitely falling off the face of the earth, so we're heading towards negative infinity. As we go to negative infinity in the x direction, where is the graph going? It's definitely going down to negative infinity. So now let's look at increasing intervals. Where is the ant crawling uphill? So there's two spots. There's this section here, and then this little section here. Okay, so that first section starts from negative infinity, and it goes all the way until this x value, so negative 1.574. Again, you connect them with a union symbol. That second interval is between these x values, so 0.409 and 1.164. Those are your increasing intervals. Decreasing, where the ant is crawling downhill, you also have two sections as well. So one there and one there. So for decreasing, it starts right about here, so at that x value, which is negative 1.574, and it goes until this x value. I'm running out of room, 0.409. So that's your first interval. Connect them with a union symbol. Your second interval starts here at that x value, so 1.164, and it goes until positive infinity. Okay. I know it's a lot of information to retain, but it is so important that you are able to identify maxes and mins, increasing and decreasing, domain and range, and end behavior.